So we will be starting our next session. Next session will be taken by Mr. Sandeep Ghoshal. Mr. Sandeep Ghoshal is an applied scientist at Oracle, where he works on agentic LLM, research with focus on text to SQL, automatic prompt or optimization, and advanced LLM fine tuning methods, where he spends his days teaching large language models to behave like reliable agents, and his nights trying to convince them not to hallucinate. He holds a BTech degree in computer science from Institute of Engineering and Management, Kolkata, and MTech degree from IIT Bombay, where his thesis work was published at AAAI 2017, back when transformers were still just electrical hardware. After IIT, Sandeep, Mr. Ghoshal worked in Singapore for a while and eventually joined Oracle. His recent work on LLM fine tuning was presented at Oracle Cloud World 2024, an event with nearly 20,000 attendees. Beyond research, Mr. Ghoshal enjoys high altitude Himalayan trekking and has completed numerous expeditions over the past decade. Alongside, he is also deeply involved in the Bay Area theater community, frequently acting and directing in local productions. I would like to I would like to invite Mr. Sandeep Ghoshal to start the session.
Okay, can you hear me?
Yes, sir. Yes,
Am
sir.
I
Yes, sir. You are
okay?
audible. You are audible.
Okay. Great. Also, can you see my screen now?
Yes, it is visible.
Because I model strategies and techniques. Okay. Okay. Uh, hello, everyone. So I am Sandeep. Thanks, Shomendu, for inviting me and the very nice introduction. So I was also enjoying the previous session, very informative. I just have two very quick points for you. I think two questions that were asked. One is what is K-means plus plus? So in K-means plus plus is just, this is a tricky thing. What we do is, rather than just to take three random points, we first pick one point, then try to probabilistically choose two other points which are farther away from the first point. Like I'm saying, first point is chosen from random, then the next n minus 1 points are chosen in a way they are further away from the chosen points. So if my one is here, the next one may be there, the third one may be here. So based on that, that's how the initialization helps us to have a better centroid position, and it's a faster uh, convergence, I would say. That's one. The second, I guess, the question was what is K-means versus K-medoids. So means a means is the centroid. Means if you have 3 points, 1, 2, and 6, the say, okay, let's say 1, 2, and 6. Yeah. So the total is 9. If you take the centroid, like mean, that will be 3. However, medoids has to be one of the points. So that's the mean point, what is at the middle. So if we take 1, 2, and 6, the means is going to be 3 because 9 divided by 3. However, the medoid is going to be 2 because 2 is the point which divides two other data points. It balances because 1 is on the left, 6 is on the right. I hope I answered some of the questions. In case you wanna know more, please let me know. By the way, going by today's presentation, I will be talking about optimizing large language models. Previously, I said this is going to be fine-tuning like language models, but then I thought like it's not really always about fine-tuning. There are other methods as well. We use optimization strategies. My overall talk will mostly be focused on the industry applications. And if you have any question, I am quite fluent in Bengali, English, and Hindi. So please feel free to ask in any language and feel free to stop me also anytime. So let's get going. I think thanks Shomendu already. So we'll be talking about 4 topics. So first is foundations of large language models. The second is evolution of fine-tuning techniques. Third is the new era automatic prompt optimization, which is an active research nowadays, and the use case NL2 SQL for large schemas. That's a application of LLM, I would say. So let's come to the foundations of large language models. Question: what is an LLM, right? What is a large language model? I say it's a probabilistic function. So given a sequence X, its job is to predict the next token. Yes, we call it token. Which is similar to a word, you can say, but not exactly. However, it's an unit of text, you can say. So our job is to predict Y given X. X is a sequence of tokens. Now, as I am speaking, this can be X, and the next word, what I'm going to say to predict, or what's to complete the text, you want to predict the next token is its job. That's Y. So that's the argmax of Y given X. So implemented as a deep transformer with self-attention, positional encoding, multi-layer feed-forward transformations, token likelihood maximization. If some of these terms are you are not familiar with, I can understand. So I will give you a reference to a video. I would very much encourage you to watch that. You will understand what a self-attention is, what positional encoding is. Very nice YouTube video that I found. It's about 1 hour. I would say you will get some visualization idea of how transformers really work. So yeah, fun fact, there is a rumor that the original Transformers paper, 2017, by Mr. Ashish Vaswani, was actually rejected first time for being too simple to work. However, this is a rumor, nobody knows. This is the lecture I was talking about. I can share later as well the slides. Visualizing transformers and attention. I would highly recommend that you watch it after this. Uh, Question that why transformers won, like why there are so many methods, so many research strategies people are doing on text, there are LSTM to recurrent neural networks, but why transformers are so popular today? The reason is not more than statistics. The reason is hardware, I would say. The parallelizable attention, scaling with hardware, global attention context. So when I say global attention context, it means that it's kind of, if you look at the attention matrix, it has access to the whole together, rather than like LSTM, long short-term memories, where we have a problem of looking at the previous tokens or going by previous, how far we can go in the context, because you are writing a document, a very large document. After 1,000 words, what would be the next word? Here we have that feasibility of, we can see the whole context and then predict the next word. And yeah, parallelizable attention actually helps us to train such models in GPUs. However, those are days or sometimes in months. And scaling with hardware is another, because things are kind of faster when you work with such parallelizable models. Next, scaling laws. So this is also a very famous paper from OpenAI by Jared Kaplan. You can see how they're talking about how the loss actually decrease based on the compute size, the dataset size, and the number of parameters. You must have heard today we are talking about LLMs, like some models like Llama 7B, for example, Llama, I would say 17B. Then we have something called 70B, like 770 billion parameters. So we talk, and you have more, like 400 billion parameters, or we don't know how much is the GPT parameters. However, the OpenAI releases 2 open source models recently. Recently means a few months back. Their GPT OSS 20B and 120B, means a 20 billion model and a 120 billion model for people to try around stuff. Well, LLMs are great. We all use them today, right? However, there are even the frontier LLMs today fail at many tasks. Say questions like mostly on the reason, because you must have heard today people are talking about reasoning models, like model who can actually reason before they answer the question. Like the token is not immediately generated, rather the model first try to figure out how to solve a question and then solve it by step. So this is first a multi-hop transitive reasoning. Let's say A is better than B greater than C greater than D. Who is the second tallest? Models always get confused. You can try with, I would say, you may, don't try with GPT-5, but you can try with other models, or maybe a smaller model, maybe. Second, conditional logic with negations. If none of the red curves are fast and some of the fast curves are electric, what can you infer? So high errors due to this negation handling, because we said none of the red curves are fast. Sometimes it gets confused with these words of none of the red curves. Non-trivial probability puzzles, well, they are really hard for everyone, even for humans. Graph reasoning, what's the shortest path after removing node C? Like this type of questions, if you ask, what sometimes human, we just looking at it visually, we can solve those problems, but the LLMs are not. NP hard problems, they are hard anyway. Hard integer linear programming problems. I was having an intern right now researching on this on ILP solver, that how good we can do with LLMs or some other techniques. I will tell about a short note on this later. Long horizon planning means some questions that cannot be answered immediately, that maybe you need to perform 20 steps before you answer a question. Say a kind of a research question where you first find something, you go to A, then B, then C, and you need to formulate a lot of stuff, get a lot of information before answering that question. And large schema linking, I will talk about this in a later part of the presentation. Hopefully I'll get time for that. Coming to fine-tuning large language models. So question is why to fine-tune, when to fine-tune, how to fine-tune. First question is why. Okay, so for customization and flexibility, improved accuracy, data privacy, better context understanding. Yeah, you can skip these terms for now. I will come to this. When to fine-tune? That's $1 million question. Let's take an example. I'm showing you one of the frontier models that's provided by Cohere, and that actually supported by the organization I work for, that is Oracle. This is from a year back though. Recently, the reasoning models probably will be able to solve it directly. But if you see, this is a very basic mathematics, probably in which class? I don't know, maybe in third standard we teach this. Question is very simple. Let's look at it. Someone got 58 roses, red roses, 45 white roses, 32 yellow roses, and then they gave some of those 24, 67, and 18 roses. How many more roses does Mr. Santiago have than Mrs. Carrot? After they both give her 10 roses and received 5 additional red roses. So you see, this is a very simple question. So what it says that Mrs. Santiago has 58 minus 10 plus 5, 53. Mr. Garrett has 24 minus 10 plus 5, 29. Therefore, this has 53 minus 29. Of the answer is 24. So what went wrong here? You see, this is the part where it got confused. It made 24 minus 10 plus 5 equal to 29. I'm giving you this is a real example that I got, because this chat window I showed, it actually said this like this, produces this output. So 24 minus 10 plus 5 equal to 29. And then you can see it says 53 minus 29, 24. So there it got wrong. However, the actual answer should be that 24 minus 10 plus 5, 19. Then we should say this is 34, and then the answer should be 34. So this type of maths, these models got confused with, well, they are text-based models. They are initially, they were not, the plan was not to solve them, solve mathematical problem. However, we are here today. The question is when to fine tune. You can see when the actual model is failing to perform. Question is how to fine tune now. So we take a pretend LLM, okay? So say a smaller one, say a Llama 7 billion model we take. Then we have some domain specific data set, which we call an instruction fine-tune data set. For now, let's call it instruction-based fine-tune. Means you will give one question or some set of instruction, and then you will give a possible answer, like how you want that to be finished by the model. And then the model will fine-tune on that. I will show you one example of these data sets, how they look. So I actually did a live demo of fine-tuning because they are quite easy nowadays. You are just a few button clicks away from fine-tune a model by the organizations. They are providing the platform. You don't really need to have your own GPUs and stuff to do this. However, it also costs a lot of money because GPUs are very, very expensive. So what we do, a very simple diagrams is you have a pretend model, you have a data set that you want to fine tune, and then you somehow you fine tune that and you get a fine tuned LLM. And then you ask the business users, they ask the question to the LLM and they get very domain specific answer. For example, you can take medical domain where the data is not really available in the internet. People, this is a very common practice. They fine tune LLM on their own data because then the model starts understanding the medical terms, or sometimes very, very specific domain, say a very specific section of auditing, and there we don't have any available material maybe in the internet. So they are like law, audit, such stuff. People fine tuning really helps. So I'm just showing a very simple pipeline how right now people are providing the infrastructure provider. They are providing a fine tuning pipeline. You have a pretend model, and you have a bucket object storage cloud where you update a data set, then you fine tune, then you have some fine tuned LLM, and they also provide you to host the model somehow. Host means something like ChatGPT. ChatGPT model is hosted somehow, so you can also have your fine tuned model hosted somewhere where you go and you can simply chat with the model. And also, that's not enough. After fine tuning, one most important task, well, I say, where actually research starts, that is hosting, sorry, validation. So after you fine tune, you have no way to know whether the model works or not. So these frameworks actually provide a validation platform as well, where you can actually say how good on a validation, reserved validation data set, you can actually know after fine tuning how good the model is performing. Yeah, if it's
Hello, sir. Your voice is breaking.
you can fine tune again. If it pass, we can go and post it. You can see my screen, right? Can you?
Your voice is breaking. Hello.
Yeah, I just stopped the video, maybe some network issue. So
Yes, now it's okay.
can
Now
you,
it's okay. Now
okay,
it
yeah.
is okay.
So can you still see my screen though?
Yes, yes, yes. Your screen is okay.
Okay. All right, cool. Okay, so we will see some of the fine tuning techniques. I will just touch upon this. This presentation is not really about talking about every fine tuning strategy. However, I will go with one or two strategies. Classical full fine-tuning, instruction fine-tuning, reinforcement learning from human feedback, very, very famous approach around the 2022. Then comes LoRa or Q-LoRa, that is a parameter efficient fine-tuning. LoRa means low rank adaptation. And generative reinforcement with policy optimization, that is a GRPO, which became very famous, I guess, last year in around 2024. So classical fine-tuning is all weights of the model actually gets updated. When I say all weights means that the billion, if you have like a 70 billion model, you actually update 70 billion parameters. You can see that's a very resource intensive and time intensive task. No one really does that today, except the frontier models. If you're kind of trying to have one model, new model, introduce a new model. Even those models, I believe they take some other models and they try to build up on that. So reinforcement learning from human feedback. Um, what we do here is, let's see, this is a very interesting strategies because finally these are text models and they want to be like humans. So the trick is a very, very smart way of doing it is they ask other humans, they show other humans two outputs. I think if you use ChatGPT or any other large language model today, you will see sometime it shows us two inputs and say which one do you prefer. So it comes from there. So there we are actually being that human to provide that feedback. So it's a model that is trained on given two output. It can say, okay, which one is preferable. So rather than saying something is 0, 1 or so, it's just using the humans to say which output is preferred. uh, I should have actually put an example. I can show you later. So this second is that's the reward model training, that humans rank multiple candidate answers and we train a reward model predicting human preference. And the third one is reinforcement learning. So after generating the response, we use this re-ranked training model to optimize the final output of the model. So it's a reward model training. It's always giving you reward. I will give you an example how reward actually works. Uh, this is GRPO. This becomes very famous last year, I believe, when the DeepSeek was introduced. So this reduces reliance on the human preference annotation. So what it does is more stable than actual PPU and better suited for generative tasks. This is very focused. So what it says is, say we are trying to train or fine tune a model based on SQL. So it says that reward is more if that SQL is valid, means whatever you generated, the SQL statement you generated, that can be executed. Plus one, if the column names match the schema name. So you see, it's very strategically giving you the rewards. So if the column names match the schema, means otherwise you are hallucinating. Plus one, if join types are correct, means if you are joining two tables, they have the proper join. So this type of reward signal it gives. And also like -2, if you have a hallucinated table, like you generated a table and the table doesn't exist in the schema. I will give also a very deep example of how NL to SQL works. NL to SQL, when we say this is a language to SQL, this means I am asking a question in human language. The model should be able to convert it to a proper SQL query based on a database and the things that we learn in DBMS. So from human language to relational database queries, and that query can be executed and the result can be shown back to the user. I will give you one detailed example of that. And you can see they are giving a -3 for syntactic errors, means if that generated SQL is not executable. And the very, very, very famous method, that is LoRa, or this is the low rank adaptation. What it does is, till now we are talking about updating LLMs, right? So when we say this is, let's say this is the pre-trained weights, okay, let's say this is 70B. what Laura has suggested is you do not touch these weights. They will remain as is. Rather, we will add an additional small module and I will only update that and you attach these two modules together. So you can see how the updates occur. The actual data, like when you are fine tuning, it will pass through this and this, and when they will update only this part on this is a very small in compared to that say 70 billion data. So the good thing about it is the resources we need is very small considering to others. As I said, GPUs are super expensive, believe me. And you can see this is 1,000 times cheaper than a full fine tuning. And it's very easy to merge multiple adapters. I will show you in a moment how this works. So model, let's say 65 billion model, if you are full fine tuning, that will require 780 GB. That means 800 GPUs. If we use, we need at least 800 GPUs. And as I mentioned, 800 GPUs, you can check the price. They are super expensive. So here, in a full fine tuning, you need 780 GB, and in QLoRa, that part become 48 GB. If you are experienced with fine tuning and you know that this is going to cost us a lot of money, that's 780 GB, and this is 1/8 of that QLoRa part. So yes, so this is, and also you see this is an adapter pattern. When I say adapter pattern, what does that mean is, I think I have a slide. Okay, I'll come back to that. Anyway, now let's talk about the data set. Okay, how do we really fine tune? If you see, this is a very standard procedure of fine tuning. Like you have a prompt and you have a completion. Simple, like how we teach reasoning models is this. So this is a maths data set, the same one I showed you before, where it was not able to solve that red roses problem. So you have this input and you have this completion. So you see this as a reasoning as well with the completion. So like let's call the certain number x according to this information given, and then a number divided by 10 is 6, and like that. So you can see that's how the model actually have the reasoning also. So before answering a question, you reason. From the input, you try to reason it and then answer it based on that solution, rather than just saying the answer will be 105 or the answer will be 10. So that's where it comes. We teach the model to reason. Okay, and there are more advanced techniques now where we call a planner verifier. Like the model actually first plans, shall I create a variable x, then I should assign a value to that variable x, then I should create an equation, then I try to solve that equation, then I go back to that answer. So something like that. So it's all in the training. As I said at the very beginning, these are a probabilistic text token predictor. That's all LLMs are. And of course, this is inductive learning, means it always tries to learn from examples. There are no baselines in a way. It's not learning from some theoretical knowledge. Rather, it is learning only from examples. I'll skip this part for now, because anyway, this is showing some part, like if you want to fine tune a model, how much actually you require, how much of a GPU you are required to train it. However, we generally do it in Python notebooks, given that you have the GPU available. Yeah. So what is the good part of LoRa that one I showed before is this. So in industry, when you say you have a customer, you have a base model that is Meta Llama 370B. We can actually create 3 variants of the same model. And you see, this is one is fine-tuned on summarization, another is fine-tuned on email generation, another is fine-tuned on support chat, because this is a 70B model and these are very small. This can even be like in MBs, this data, because of these are only, if you look at it, the adapters. So you have one base model and a series of adapters. So you have a fine-tuned summarization adapter, you have an email generation adapter, you have a support chat adapter. All 3 are actually fine-tuned on its own data set. So that's where it comes, like why that LoRa is becomes so famous, because it's very lightweight and easy to expand to many. Well, LLM fine tuning also superb. However, let's think about it. We used to chat with LLMs all the time, right? So if we just ask what's the temperature in Kolkata right now, what is the current price of some company's stock, what's my current SBI account balance, do I have any meetings tomorrow at 2 p.m., show me all orders shipped last week, find me the cheapest flight to Seattle next Monday, where is my Amazon order? Okay, I'm showing some personal questions here. Can LLMs answer, or can even an agent that is a very personalized to your agent, can it answer? Well, no, because there is no way, even if you fine-tuned a model, say you fine-tuned a model 10 days back, will it know where is the status of your order next week or 1 week back? Because it was actually trained 10 days back. So it has no way to know what happened after that. The question is how we can solve these problems then, right? Tools. We have some method that is called tool calling. So what today's frontier and all the LLMs are trying to do is, they don't try to answer everything. Rather, they are providing an option that is called a tool call or function calling. You must have heard this term, function calling. So LLMs don't answer, rather they invoke some function or some API. So for the first one, you are given one API call. Okay, this is weather.com. Whenever you get some weather question, you just call this method, get weather city equal to Kolkata. My bad. So I misspelled Kolkata here. I'm sorry about that. So get weather city Kolkata. You get stock price Oracle. Someone else already wrote such APIs. Someone will check the stock market and let you know that what is the point. All you need to do is just to send the argument and choose the correct method. However, this becomes a challenge. There may be 1,000 such methods, but still, we can see that this is an easy task for LLM to do. Simply call a tool that your next token will be get weather city equal to Kolkata. Same way, it can actually check your calendar if you provide it that your calendar access. Let's say your phone assistant that has access to your calendar app. So it can check your Outlook or it can check your Gmail, and it can say what meetings do you got in next tomorrow at 2 p.m. So same way, it can check your, let's say it has an Amazon API, it can check your orders from last week. It can find the cheapest flight looking at Skyscanner or any Google flights and search for the API and rank the flights. So that's possible. That's kind of a smarter way of handling tasks rather than try to answer everything on my own. There is no way we can know. Like what we do, if you ask me what is the right now weather in Delhi, I have no clue. I will just go and search like what is the weather in Delhi, and that will take me to some API. And there is weather.com or there is some other weather providers. From there, I will get it. So we are just trying now LLMs to also do a similar thing rather than answering everything itself. Call tools, call methods, call different functions. All right. So I will stop here. Do you have any question until now? Because we will be switching to a very different topic after this. Please feel free to ask.
Sir, there is one question asked by Ajiteshmoy Ghosh. What is the break-even point an organization consider LLM for future activity?
Hmm. Okay, can you clarify more on that? Like, what exactly do you want to know? Please feel free to say.
Ajiteshmoy Ghosh, if you can unmute yourself and can ask the question.
Yeah.
Yes, good evening, sir.
Good evening. Good evening. Yeah. It's morning, by the way, very early.
Yes, yes. Good morning
Yeah.
to you. Uh, so my question is that we all know that LLM and generative AI, all these things we are using for better results for business perspective and for other activities. But suppose an organization who is actually working on the data science field, but now want to migrate to that with LLM feature, generative AI feature, all these things. So when
Hmm.
exactly, my question is when exactly the organization can think about it and consider that particular uh, uh, activity or architecture uh, in place so that they can get some better business uh,
Hmm.
revenue or something like that.
Well, yeah, let me tell you, most of the computer oriented organization, I would say IT organizations, they're already there probably, I would say. Okay. The question comes for outside non-IT orgs, because IT orgs are like probably it was released in 2022. From then to its end of 2025, it's been 3 years. So most of them are already onboarded with generative AI. Even if they don't need it, they are using it. Believe me, because it's very cool to use and say that we are using also generative AI today and LLMs. However, non-IT orgs. So what the industry is today going is more to agentic frameworks. We call it agentic. That means you have a very specified agent that is good at some specific tasks, say a flight assistant or a travel planner agent that need not know everything in the world. Like, I showed some APIs right here. I showed some APIs. I'm saying even some of these APIs can be another LLM, that is an agent. Like, there can be one stock manager agent, that's job is only to look at stocks. There can be another agent that is a tool planner, that's job is to it has access to all the tool related, like a hierarchy of agents that people are using. However, these are still, I would say, still at the very much on the IT level. Do we really use for other industry? I don't see yet much use cases. Actually, medical is there. Medical domain is going very, very fast with this, because they have their own terms, medical terms, because they are also text based, right? Uh, However, if you ask me, also we see some of this travel planner and anything that is online, they're of course using LLMs. However, outside that industry, like let's say some manufacturing industry, um, are they using it, or how much really they need it? That's a question. So yeah, the break even point is, it's I would say it's subject matter experts. They know the right answer, but day by day, I would say more and more people are actually uh, getting used to it and starting to use it. Uh, I hope that answers your question. Uh,
Yes.
all right.
Is there
Let
any
me.
other
Am I
question
audible,
from the audience?
Yeah, sure.
sir?
Is there any other question?
Hello. Yes, sir.
Hi,
Am
hi.
I audible, sir?
Yes,
Yes, yes,
yes,
you
yeah.
are audible.
My question is related sir, to some extent text. My question is
Your
that
call is
if the
your call is
sense
breaking.
is
Your
changed with
voice is breaking.
Yeah.
hello, sir. Right now
Hello.
am I audible, sir?
Yes, yes, you are
Yeah,
audible.
yeah.
Related with the LLM, sir. Of course, to some extent, LLM is helpful for the test data. But if the sense is changed with the representation of the test tokens, ABC, capital ABC, and another combination of token is capital A and small bc, and another combination is A capital and small b and last C is capital. In that case, how LLM will be helpful? Because suppose in case of the data, we are handling the data of the traffic control, network traffic or malware sample. In that case, sense is changed with the representation of the alphabet. It means tokens, if tokens will be represented with the different lower and small cases, the sense will be changed. In that case, how LLM will be helpful? Sir, my question is related with this.
Okay. Yeah, it's very interesting question. I never thought about it before.
Malware,
Well,
in case of malware, suppose API call, if the alphabet will be changed, and in case of network traffic, if the digits representation will be changed, the sense will be changed. If the representation and sense is in normal cases, it's okay. But my question is related, if the representation of the alphabet are numeric, in case of numeric, no problem, but alphabet, if the representation with the change of representation sense is changing, then how LLM will be helpful? In case of the malware samples, that is the problem, and in case of network traffic, that is also problem. So how LLM can be helpful, sir?
Did you try something like, and do you have any example that it failed, or like is it more of a theoretical concept? Because I can think about some of the token representation ways of how can we actually handle it. But let's say if you say small a, small b, cap c, okay, this is very in your way, it's very different than small a, capital B, and small c, right?
Yes, sir. Yes, sir.
Yeah. So yeah, so one thing is like we need to represent these two tokens separately. You see, they are exactly that fine-tuned and things come into action, because the original model, they may not be trained like that. But if you provide these two examples, okay, that A caps B C and A B caps C are different from two different classes, so there the models will, however, I think in this case, probably we might require a new tokenizer, because you need to train a tokenizer as well so that the model can understand. The way I see it, this is not very common, because this is not really literally the, in a way, English, right? However, since we are working on, I didn't never actually work with this problem that you mentioned. Very interesting. I'll try to figure out.
Actually, sir, I have faced this type of data set, sir. That's why I asked, sir.
Yeah, I can understand. I think you need to train or extend a tokenizer in this case, because I don't see a way, because if it's tokenized differently, these things like ABC and A caps BC are same to it otherwise, if not properly tokenized. So the way I see it, you probably need to try out with a tokenizer. You just give it a shot, I would say. Okay. Before even fine tuning, have a tokenizer first. Train a tokenizer. I'm sure, like, we generally don't need to do that very often, but I think this is a case there. All right, that's a great question. Thank you for asking. Okay, I will stop the camera.
Yes, sir. Yes, sir. Okay. Actually, after tokenization, generally root word is created, and in case of this, in my case, a root word generally alphabet and lower and upper. Generally LLM is applicable in that case where lower and upper case doesn't change the sense. Sir. Okay, sir. Okay.
Right. Yeah.
Okay.
Yeah. You're right. Yeah.
Okay.
Yeah.
Thank you, sir.
By the way, there is one other way of having these tokens as unknown tokens or outside tokens. So that's the another way I can think of right now, that if both are tagged as unknown, and one is unknown ABC, another is unknown AB cap C, this can be treated as separate tokens. I'm still trying to figure out how to handle. I'll probably get back. Okay.
Okay. Thank you, sir. Thank you.
Okay, no problem. Okay, I'll stop the camera because it's getting hanged sometime. All right. Why automatic prompt optimization? So now we are going to talk about something that nowadays, more in the last 1 year or last from 2025, I would say from last 10 months, the industry has kind of shifted from fine tuning to prompt optimization. So as I said, fine tuning needs a budget. Fine tunings must have a budget associated with it for your GPU cost, your data processing. However, there are some papers that were published during the time frame of 2023, 2024. They are saying LLMs kind of can learn themselves. What does that mean? We'll see. First is prompts are brutal because we know if you just slightly change your question, sometimes we found that the answers are drastically changing. Okay. Second is small phrasing changes like large output variations, and third is, and like if I really give you 10,000 samples, like I need this for these questions, these answers, it's not really possible for us to like handcraft, except fine tuning. I'm saying handcraft the prompt or given different types of instruction to solve such questions. So what the APO means, automatic prompt optimization. Okay, so what we use is generate prompt variants, evaluate variants on dev set, then select some survivors, muted prompts. I will see this. We'll see this in a moment. Let's see what happens. Okay, so first you have a system prompt, a very small. I will show you an example of how a system prompt looks like this. Say you will answer a reasoning question. The last line of your response should be a following format: answer, value, value. The value is one of the tools. So when I say tools, I introduce you to the tools by the examples of different types of tools. So let's say I said I want one or two tools in the example. So how this works now? It then first we give an initial system prompt, then we give a few more examples to this. Then we have a system where we actually try how the current system or the current prompt is working on these examples. So some examples you can see this is like a trend test set. So for some it will be correct, for some it will be wrong. So for the wrong part, we use another LLM. It is called LLM as a judge or LLM as an evaluator. So this is evaluation prompt is, you see, its job is you are the gradient feedback engine, and your responsibility is to give intelligent. We generally use some powerful LLMs here, okay, which are good at reason. So say the answer should be apple, but your answer is orange. So we give it and we ask another powerful LLM to reason what went wrong. So what in the initial prompt, what was missing in this instruction, so that went wrong and it could not predict what it should have predict. So this is a gradient, and we ran a mini batch on these gradients. Means if you have, let's say, if you have total of 300 examples, and these are like your batch size is 3, so you will have 100 such batches running, and for each batch it will create some feedback. And after that, you see this is a series of feedback it gets. Then we ask it that, okay, optimize the prompt. When I say optimize the prompt, that means optimize the system prompt, the base prompt that we used. So now, based on what it was not able to perform, we reason, we give feedback, and we ask it to improve your initial prompt. So now that prompt is, you can see here that your job is to improve the text. So this is again another LLM. So there is no human in this loop. LLMs are kind of critique itself, and LLMs are optimizing the prompt. So, and if you see the final optimized prompt, I'm showing you something after iteration 12, means after 12 epochs. From those 2-line prompts, LLM can actually generate this big of a prompt. Like you see, the first line is same, you will answer a reasoning question. It's asking, understanding the question, begin by clearly identifying and listening each item of component involved, and so Like it is saying direct answer format, conclude with a direct and clear answer format, such as this, handling edge cases, user engagement after providing the answer, offer additional assistance to ask if the user needs further clarification. So you see, LLMs kind of generated this prompt from this initial prompt through this process. So this process, what is shown here. So the initial prompt to that, I have not yet shown you the final optimized prompt. This is another one. You see the answer must be a Python list, use single quotes, general roots, return every applicable level, keyword lookup, and then it also able to create some few shorter in-context learning examples like these ones. Check the record A, for example, and something you need to call these two, like again, these are tools. This is from a data set called two-less dataset. So you see, rather than we are writing like a very long two-pager prompt, which might take a month to write for us and let LLM work with that, we are using an optimization loop to start with a very small prompt. And maybe this can be done. This can be done without GPUs. This can be done just by looping through that, and finally generate something that is like within an hour or 2 hours. So this is somewhere a study says kind of probably many organizations are actually spending more time or more money in prompt optimization than fine tuning today. So what are the example data points I used for this? This is, as I said, this is a two-less data set. So like you say, these examples are from that data set itself. It might sometimes be a little less realistic though. So I'm planning a VR gaming night and I'm asking this, could you support also the game we've released chapter today, see if there is any new VR action movie under 120 minutes to watch instead, and so on. So this is way. So you call this two, you see, you call some game, get game, and get movie, get VR game, get VR movie, and to answer this question. So all the job of the LLM is to call tools here, nothing else. It doesn't need to create response, rather just call tools. Same way, you can say, I know to gather information about John Doe's parents. Could you first retrieve his like some relations and then provide like get relations, get info. Different types of data, like get power system, get load shedding status. Like you see here, your job is not to know everything, rather you should know which tool to use. Like the way we do today, we sometimes we search internet, we look for the right site and we get the information from that. It's kind of that. By the way, web search is also a tool. Right now, if you talk to GPT, Gemini, or any other models, you can actually see they are calling web search tool. Like just like us, they also do a search in the web and then they try to figure out the answer from that. Performances. So we ran some of these and you can see after applying that loop without any fine tuning, there is no fine tuning here, just by doing a prompt optimization, how much accuracy can we actually get from like 52 to 92, 60 to 92, like 75 to 87.5%. These are some numbers on the data sets that I showed you before. And that too is with very small sample, like a 50, only 50 data I used to train that model, and it can get this much. Second is we actually plotted. So this is something, you see, this is very much depending on the model. So this is a plot of, I showed you that starting with a simple prompt, we get a very complex prompt, right? After that, after the entire optimization procedure, this is some type of plotting of the data where you can see actually how the GPT models are getting, where the Llama models are getting. So of course, it is pretty much of the model family dependent, I would say. Like how the optimized prompt will look for GPT models may be very different for the Llama models and very different from the Grok or Gemini models. This part I'm going to kind of skip for now because we don't have much time. However, I will talk about something very recent advancement in this. So people are actually trying, genetic variants in this algorithm. So I will show you one example. So when you are proposing a new prompt, the problem is expand. We need to think like, because a text can be anything, right? We should try to explore more and more and more. So here I'm giving an option of like, this example will show you that how people actually using, like, you first ask the models, you can always ask the model to say generate two prompts, and how they actually use two prompts to generate the third one and the fourth one. Please feel free to stop me and ask questions in this, because this is a very different than what we do. This is a genetic algorithm. This crossover is used in the genetic algorithms. Uh, so you see prompt one, now you are categorized, and like from here, the crossover is your mission is to ascertain sentiment of the provided text and assign sentimental level from negative or positive. The very simple example. How these two prompts are crossed over and created a new variance of the prompt. The second is determine the sentiment of a given sentence and assign a level from negative to positive. Let's say this is a mutation of the prompt. Why? Why we are trying it? Because otherwise what we can see is, as I go through this, like, you see, from the very beginning, after that optimization process I was trying, and this is where the research actually helps us. You see, the very beginning it changes, and after that it quite remains same. Like it's not really like, most of the time you won't say any improvement because of this new candidate. So since we are using LLMs to give the feedback, most of the time they got stuck. We can play around with the temperature parameter. We can see the tokens. We want more innovative tokens. Even after that, we found many times like it improves very good, like 50 to 90. Then after that, taking it to 90 to 92 or 95, it's very difficult. So this is something that we found, that when you are trying something with, say, automatic prompt optimization, you should be very, very careful. You should see how much time it takes to update the prompt. Like here, you can see I ran some examples across total epochs. I actually see like 1320 out of 1320, only 187 times something got updated. So there comes the research, like what went wrong, right? Why, like, you will see the 65% of the data is changed in the first few epochs. Even if you train for, let's say, 200 epochs, nothing is going to happen because the prompts are not actually getting mutated, because the same value is like, it is kind of beating about the bush and that area. It can't change. So people are trying different evolutionary algorithm, that is a genetic evolutionary algorithm. They are trying to see, here you see another example of, they are trying B minus C and then A plus A B minus C, where each word is trying to have a different variance of the words. So in a way, it might look very random way. It is indeed. However, we are trying to have one good example and then try different variants of that, and then evolve into some other examples. Okay, so let's see. There is another algorithm. This is called JEPA. I would recommend you go through this. This is a similar approach, but I think we don't have much time now. I would let you, like, you can find this paper here and the code base here of JEPA. This is again a very recent prompt optimization technique, where people are trying again like different types of like Pareto frontier. When we say Pareto, I just gave the example how people are trying to do. Okay, so I will skip this for now. Very recent, very like, it's from the, I guess, the August 2025. This paper was published. I will like to talk about the last topic of me today, that is NL2 SQL. That's where I told you I'll start with this demo, what I meant. You see, this is a demo we built for one of our customers. You see, a question was asked: list all customers, shop name and city, car make model from some car shop, where the mountain view imports who drives Audi Q5. You see what happened here. It generated from that question only, it was generated a SQL query, and the SQL query was executed in the database, and it returned some answers. So exactly this is the task of NL2 SQL. So given a natural language, a text question, its job is to, and of course we provide some table information, your schema information. Its job is to create a proper SQL only, and that SQL to be executed in the database so that we can get back the answer. So yes, so you can see what we give. We give the user question, we give this, we have a generated SQL, we have the database, we have the result set. This looks very simple. However, like let's see, if we ask this question, how many customers from the shop accurate motor who drives blue Audi Q5? This is so the query to be formed is something like this: select count distinct from repair order. So this is a very simple example. It's like uh, for kids example here. Like shop name is accurate motor works, car make should be Audi, car model should be Q5, and car color should be blue. So the problem is here is, if I really give you these three examples and say which one are correct, there is no easy way or text-based way to actually say like complex SQL queries to say whether they are correct or not. The only way, not only way, I would say the easy way is you actually execute these queries and then see whether the two result sets of these queries match. Because if you see, I can have different permutation and combination these values, right? I can have the car make, model, and shop name in different order, or the color. So what we need is, what we do is to validate such use cases. We use a technique like this. We run this SQL and we have a ground truth SQL, and then we need to generate the result set. Well, by the way, I will go to a very quick example of this. What we faced, like why we say when we are solving real-time problem, they are very different, like very different and somewhat interesting, I would say. We are working on this project and someone someday said, give me a list of valued customers and the amount spent for my shop. Now, do you understand what is a valued customer? If I ask any of you, like, what would you say? Who is a valued customer? But they say, no, we need a definition of my valued customer. So I'm trying to showcase the challenge of text to SQL, because free text can be anything. People can ask anything, and you need to check upon a database based on that free text. Like it's a heavily difficult task, I would say. Also, you see this question, someone means miles, someone says kilometers. So sometimes you might need to convert. Someone says 50K miles, that means 80K kilometers. You might need to do that because you don't know like what people are going to ask. So even if LLM are smart, even if LLM are doing good, even if we can fine tune, at the end, solving the real world problems are far more difficult than just that hunky-dory type of good questions. Yeah, please feel free to ask questions. Also, Shomendu, please feel free to stop me if someone has any question to answer.
Sure.
All right, so I will continue with that example, but I just want to give you a hint of how the reasoning models and how this is back in 2024 when there are no reasoning models available. I will show me interesting example of how where LLM can hallucinate. So how do we solve some problems? Like one very possible approach or very effective approach, what I found is giving example, showing example to the LLMs. What happens really? You see, new customer definition, which means visited in the last 3 months, but not in the previous 24 months. So we are trying to say what a definition of a new customer. So we are providing that as a part of the prompt. You see here, I have a valued customer definition, I have a new customer definition, and I have a new customer query. What happens in the attention, if you like understand the attention very clearly, this is quite obvious because you are showing the word new. You know how to create from a given question, how to actually create what should be the next tokens. That's all. Few short examples are all about showing how the next token shall work. Okay, so you see here the new customer queries are select distinct this driver invoice and when like -3 because 3 months and my not in the last previous 24 months. If you see, so last not 3 months, previous 24 months. So in a way, we are looking into 3 to 27 months, previous 3 to 27, right? So now you'll probably see that I did something here. I said last 3 months for this add months and a date between 3 to 20, 3 minus 3 24, 3 to 27. But you see, I never mentioned the word 27 here. Why? Why is that? Because when I really gave the word 27, I found LLM really do not understand how the word 27 came. So if you just say 3 and 15, it might again say 27 because LLMs has no information that 3 plus 24 is actually making 27. Rather, if we use the same tokens that are used in the question to the answer. So here I'm saying, okay, I'm saying 3 and 24, it is -3 plus 24. Now, if I ask you 6 and 15, it will be same way, -6 plus 15. Then it can actually work. So if I say like not, you see, minus in the 9 months to 15 months, then it can understand, okay, previously it was 3 and 24, so I did -3 plus 24. This time it's 9 and 15, so I need to do -9 plus 15. And because if you just give it a new token, totally new token, that's 27, it may not understand that how that number came. So this is, I'm giving you some real-time experience while actually working with customer problems and LLMs, what I faced. I think we are almost at the end. I won't go much right now into this part of the large schema linking. However, I will give you a very sense of what is large schema linking. It means that given an answering a SQL is very complicated task, because if I give you 200 tables, given one question, you have to map that question to which tables out of those 200 tables to choose from, and then you need to answer. So it is, I'll give you a last example how this has been solved as an optimization problem. So if you see, this is an optimization problem. So where we are saying you need to know the right table, like given the query, what are the right table to choose your answer from. Like the second is which columns from those tables. Let's say if you have 200 tables, on an average 7 columns, you have 1400 column to choose from, right? So, and the third thing is when you are using joins, which table can be joined with which other table. Like think about it, when it's not like LLMs just understand text and we are providing everything as a text. You are providing 200 tables. Probably it will probably make, and with 1400 columns, it will probably make a 10,000 or 15,000 tokens. And you are giving a one-liner question. Out of that one line, it has to figure out which, say, 5 tables to choose from and the columns to choose from, and those tables should have internal relationship, and then you can only do the joins among those tables and finally generate the queries. Like just think about it, even for humans, if I just showed you one shot, this is 200 tables, these are 1400 columns, and I have this question, can you answer that? How much time will it take for you to answer? So even simpler industry problems sometimes become very tricky and complex for LLM to answer. I will stop now. We have 3 minutes. I know it's already late for you people. So please feel free to ask any question you have.
Audiences, if you are having any question, you can ask. You can unmute yourself and can ask. Hello.
Yes.
Is there anyone Who is there any question?
No.
Then please mute yourself.
All right. I know it's late already.
Sir, I am having a question that
Go ahead.
how this LLM will dominate the business in future.
Look, I believe for a lot of problems, actually are quite easy for LLMs to solve, and this will evolve. However, I feel there will be new era and new things to come up also in the next few years. Like this is not the one and only solution that is going to be. So for a lot of small business, small problems, I think LLMs can do great. However, when the numbers become large, when the problems become complicated, LLMs also fail. But you can see some of the tricks. That's all I was trying to showcase, that how LLMs actually evolve from a full fine tuning to a lower fine tuning. From there, you are calling tools. From there, you are not even fine tuning. You are just calling APIs to solve your problems. And then, of course, we have right now image models, we have text models. We are doing a lot of things because images are also kind of trying to break it down to like tokens and embeddings. So I think LLMs are going to lead the business for quite a few years from now. However, they are going to have new architecture coming up.
Yes, it means if we take the example of ChatGPT, say, as it is a pre-trained model, so suppose if I am having a query which has not been asked before, so initially ChatGPT may give us some wrong answer. Now, after asking the query, means when it gets the input at first, so it will try training its model again, and after asking the same query after say 5 or 10 times, it might give the right answer. So how these models are trustworthy?
Well, so yes, that's what I was talking about, the inductive learning, right? Where one try to learn things from examples. This problem always occur. Like if you see, there is one New York Times reporter interviewing ChatGPT 3 years back. So it can talk about terrorism, it can talk about a lot of things, but safeguarding, that's one of the most challenging problems in the industry today that is going on. So how you can these models have not generate any unsafe information, and also not any biased information. So I thought today I didn't go into that, but a lot of research like that is called responsible AI. The point is, if you don't know something, if you don't know something, or if you are not sure about something, don't say it. Don't be confident. Be or don't share any information don't classify based on ethnicity. However, in a way, if we all see these models are learned from human generated articles, a lot of generated human generated data, somehow the bias is there inside what we have created so far, because there is no outside information in these models.
Sure. Okay, so audiences, if you are having any question, you may ask.
All right, thank you. Good job. Okay, I think we are a few minutes over. If you have any question, please feel free to share with Shomendu. Shomendu, thank you for organizing it. And,
Sure.
inviting
Thank
me.
you.
Just great.
Thank you very much. And from the whole organizing team, I thank you for your time, for your effort, for your cooperation. And I know it is early morning now.
No, I enjoyed it thoroughly. Thank you.
It is early morning, and okay, thank you. And it is really an engaging talk, and wish to have you in person in your alma mater. Thank you.
Yeah, sure. Thank
Uh,
you. Bye bye.
Bye. Have a good day. Okay, participants. So we will join tomorrow at the same time at 5:45 p.m. Thank you very much. Good night.